Hello again, and welcome to General Psychology, Psychology 101. And today we're going to be talking about the goals of psychological research. So when we talk about psychology as a science, there are three main goals that we generally have when we're conducting research in psychology. The first is to describe behavior. And generally, to do that, we observe behavior to uncover specific patterns or specific ways that people generally behave to get a better understanding of how people behave. And to do this, we use descriptive methods. So probably the most commonly used descriptive method is the observational method. This can be conducted inside or outside the laboratory. And this is basically just going out and observing people doing what they're doing. Basically, description at its most basic level. In terms of observation, generally you don't have a specific thing that you're looking for. Sometimes you can, and that gets things a little bit more specific. But generally you're going out, especially in the field, and just watching people behave in certain ways. And when you start to see patterns, start to see people doing the same things over and over again, that's when you start to formulate, okay, there may be something to this, we may be uncovering a pattern, and that oftentimes leads to conducting future research on that. Observational research has a lot of flexibility. You don't have to pinpoint yourself down on what specific behaviors you're looking for, but there is low control involved. You can't really control the environment that much. If you're looking for one specific behavior and you're only thinking about one specific influence or one specific independent variable, which we'll talk about, influencing specific behaviors, you can't specify that. You have to just go with the flow of what's happening. A great example of an observational study is a study that was conducted not too long ago, basically observing children in front of a marshmallow, trying to see whether or not they will eat the marshmallow, even though they've been told, if you don't eat the marshmallow, you'll be given another one after a certain amount of time. So this is an example of just putting participants, in this case children, in a room and watching them behave and seeing if there are any patterns to how they're behaving. Another example of a descriptive method is the case study method. And this focuses on one specific participant or individual and basically studies them pretty in depth. So a lot of times you'll see case studies occur when something has happened to an individual that can't be manipulated or doesn't happen very frequently to others. A great example of a case study was the story of Phineas Gage. He had a railroad spike driven through his head, through his brain, yet managed to survive. The railroad spike was removed. He regained pretty much all his normal capacities after a few days, a few months. But his personality was completely different. So researchers use this to not only study brain plasticity, the ability of the brain to basically move a lot of functions into other portions of the brain if specific areas have been destroyed, and also looking at changes in personality. Another example of a research method is survey method. This is basically just asking people questions and having them respond in any way they would like to. Sometimes you'll see this occur over the phone, sometimes you'll see people write responses to this. And basically it's just taking down notes, describing how people respond to certain questions. The wording of the questions that are given to participants can be especially important, but again, similar to the observational method, this is just a way of getting a better idea of how people behave, or in this case, how people think or how people feel, and how people report this to others. So those are some of the ways in which we can describe behavior. Another goal that we have as researchers is to predict behavior. This is extremely important when we want to predict specific behaviors that maybe we want to increase the frequency of or decrease the frequency of. And generally we want to identify the factors that coincide with when a certain emotion, a certain cognition, or a certain behavior occurs. To do this, we use relational methods. So examples of relational methods is, probably the most important one is the correlational method. And this is assessing the relationship between two different variables. So we can think of a lot of these. So for example, what's the relationship between smoking and cancer? What's the relationship between depression and suicide? Ideally, we want to try to eliminate suicide and eliminate cancer. So if there's a positive relationship between smoking and cancer, we can say, hey, there's a good chance that smoking is causing cancer. We can't say for certain that it causes it, but we can say that there's a relationship there. Similarly for depression and suicide. If these two things correlate with each other, if as depression increases, so does suicide, and as depression decreases, so does suicide, we can say that there is a relationship there, or a correlation, and that these two are strong predictors of each other. However, we can see certain situations where two things may predict each other, but don't necessarily cause one another. So a real-life correlation that we can see would be as ice cream sales increase, so does the frequency of murders that occur. So hopefully it isn't the case that the more ice cream people eat, the more they want to murder people, but it could be the case that there's some other variable occurring that is leading to the increase in both. So for example, the hotter it is outside, the more frequently people get ice cream. And we also see that heat increases aggressive behavior and can subsequently increase the likelihood of murder. So even though ice cream and murder are correlated, there is no causal relationship there. There are other variables that are influencing both of these two variables of interest. Another example of a relational method is the quasi-experimental method. And this is used when we want to examine some variables experimentally, but we can't actually manipulate a certain variable. So for example, when we want to compare two naturally occurring groups, so when we want to compare men and women to each other, we can't manipulate if each individual participant is going to be man or woman. We have to use the naturally occurring distribution. Same for nationalities. If we want to compare Americans to Canadians, we can't manipulate whether a person is going to be American or Canadian, but we can evenly distribute Americans and Canadians across our subject population. And basically this allows us to examine things experimentally and basically see if there's any commonalities between groups or differences between groups. But it's important to remember that this is not true experimental manipulation. This is still an example of a relational method. Finally, the last goal of psychological research is to explain behavior. And this is done via experimental methods. And this is probably the most important type of research that is conducted within psychology. We want to try to determine causal connections between variables. We want to figure out, okay, if this specific behavior is occurring, why is it occurring? And if it's a bad behavior, how can we prevent it? And if it's a good behavior, how can we increase it? An experimental method is by far the most common type of research that is conducted within psychology. This is when we manipulate certain variables, say, for example, whether a person sees a red light or a green light, and then we measure a certain variable of interest, say, for example, aggressive behavior. So we can determine if the light that a person sees may increase or decrease aggressive behavior. During these experiments, we try to control the environment as much as possible so that way we're only manipulating one specific variable, our independent variable. So in the example that I gave, we might have people come into a lab, have two identical labs, one with a red light and one with a green light, and we give each participant the exact same treatment, tell them the exact same things, have them do the exact same tasks, and we see if there's a difference in the amount of aggressive behavior that they conduct. And for this reason, most experimental research is conducted in a laboratory in order to control the research experiment as much as possible. And there are also some other techniques that we can use to control the research experiment. For example, if we're interested in measuring emotions, we may want to put everyone at the same emotional baseline from the get-go. So we might show everyone a neutral emotional video, or maybe we want everyone to start happy, so we'll show them a video that will make them happy, and then we'll conduct the experiment to see if differences in, for example, emotional manipulations changes other types of behaviors. Now, experimentation isn't without its flaws. People aren't always truthful in how they respond in lab settings. People often just simply don't do what they're told. And labs are often not like real life. Sometimes it's very difficult to say what happens in a lab will also occur in the real world. And a lot of times, this type of research is conducted in a university setting, and most participants in university settings are weird. And what I mean by weird is that they are white, educated, industrialized, rich, and democratic. Obviously, this type of person is not representative of the entire population of the United States, let alone the world. So it's important to take a lot of the research that's conducted with a grain of salt, knowing that the participants may not be representative of the entire population, but at the very least, it's a start. And then we can conduct subsequent studies using a more diverse, a more diverse subject population. But this kind of underlies another important part of research, is that we shouldn't just be conducting one study and stopping there. It's possible that there are certain aspects of the research or the experiment that we've conducted that encourage the specific pattern of data that we collected. And one specific result that we get does not signal a truth. We need to replicate studies as much as possible in different situations, in different labs, in different settings, to make sure that the relationship that we think might exist does actually exist, especially that it does exist in the real world. So replication is extremely important. Sometimes we'll find that extraneous variables that we didn't know existed will pop up after the third or fourth replication, and that's why we need to conduct this research. And for this reason, we find that theories that we might have initially thought were completely true, set in stone, aren't going to change, are sometimes in flux. They are changing over time. People thought that the sun revolved around the earth, and we know that not to be true. So we have to keep an open mind when reading and hearing about a lot of the research that we talk about, because there may be completely different ways to look at these relationships and theories that we haven't thought of yet that can shine a whole new light on these relationships. So need for replications are important. A very good real world example of this is for those of you who have been watching the news for maybe the last couple of decades, you know that research on eggs has been all over the place. 1 month, research will say that eggs are good for you. The next, they'll say that eggs are bad for you, that you should stay away from them, and then it'll kind of flip-flop back and forth. So these kind of flip-flops, these changes in the understanding of how beneficial eggs are for your diet are because of people are kind of taking a different look at this research and formulating new hypotheses, new understandings of theories, etc., etc. So that's all we have today. Thank you for your time and attention, and I will see you next time. Bye-bye.